In this session, we are going to discuss Venn diagram and operation on sets. Now, Venn diagram is the representation of sets and the operations on sets in a pictorial manner. Now, the word Venn diagram is given in honor to the mathematician John Venn, who formulated the Venn diagram or who invented Venn diagram. Okay. Now, let's see how the universal set and the other subsets of universal sets are notated in a Venn diagram. The universal set is represented by a rectangular box. This is the universal set. And the subset that is defined under this is notated by circles. So, this is set A, this is set B. Now, here you will write the elements of set A, here you will write the elements of set B. And if anything is in common to both A and B, then that will be written here. Right, the joining part. Now, let's see what are the operations on the set. So, operations on the sets. The first one is intersection of two sets. Intersection of two sets. Right? The intersection of two sets. Which is the intersection of two sets? That is this part. Right? This is the intersection of two sets. So, how will you find the intersection? That is notated by A intersection B. A intersection B. Or I can even say that intersection of two sets means both that the elements which are common to both A and B, right? That is both elements in both A and B. Notated by what? A intersection B. So, A intersection B is the set of all x such that, yes, such that x belongs to A and x belongs to where? B. This is how I notate belongs to. X belongs to A and x belongs to B. That is, it is common to both A and B. Right? The second one is the union of two sets. Union of two sets. Notated by A union B. Right? A union B. Now, A union B or the union of two sets means that is the elements in A and B. Right? Here it is elements common in both A and B. I forgot. Okay, I missed out on common. Element common to both A and B. Here it is elements in A and B. So, A union B is equal to what? Set of all x such that x belongs to A or x belongs to B. So, all the element that belongs to A and or x belongs to B. That is, x is all the elements in A and all the elements in B. That is, their union means all the elements of A and all the elements of B. The intersection means what? The common elements. The common elements in A and B. Okay. So, this is the intersection of two sets. Now, the third one, the concept is the disjoint sets. What is meant by disjoint set? Two set A and B are said to be disjoint. I'll show you in the Venn diagram how it looks like. This is A, this is B. What is the peculiarity here? What can you see here? That is, none of the elements of A is common to that of B, nor none of the elements of B is common to that of A. That means their intersection give you a null set. So, if the intersection of two sets gives you a null set, then the sets are called to be disjoint sets. Okay, so there is, this is how we represent A intersection B. Got it? So, that's it. Now, let's see the union and intersection and the disjoint sets in a Venn diagram. So, first one what I am going to draw is A union B, the union of two sets. So, in the Venn diagram, this is the set of the universal set. This is set A and this is set B. Then the union of A and B is what? This shaded portion. This is A union B. Now, what is A intersection B? Intersection B means what? There are two sets, say A and B, and their intersection, common, right? This is A intersection B. And then disjoint sets we had already discussed. What was disjoint sets? Two sets A and B, which is given under for the set of universal set. Under the universal set, you have two sets A and B, and this is how the disjoint set appear in Venn diagram. Disjoint set. Okay. Now let's see the algebra for sets. The laws of algebra of sets. Now the first one is, if A is a set, then A union phi. What is A union phi? A union null set, which is equal to A. Now, A intersection null set will be equal to what is common in A and null set? That is null set. Okay. So, this is the first law. Then comes the commutative law. Commutative law. If A and B are two sets, then A union B is same as B union A. And A intersection B is same as B intersection A. Okay, so that is the commutative law. Next is the associative law. Associative. All these laws is familiar to you. A union B union C is equal to A union B union C. And A intersection B intersection C is equal to A intersection B intersection C. So that is the associative law. Now we come to the distributive law. Distributive law. Now the distributive law. So A intersection B union C is equal to A intersection B union A intersection C. And A union B intersection C is equal to A union B intersection A union C. Okay, so what can you say here? Intersection is distributive over union and union is distributive over intersection. So this is the intersection law. Now, if I am giving you a note, if A is a subset of B. What is A? A is a subset of B. Then what is A intersection B? Which is more? B is more. A is contained in B. So A intersection B will be what? A. Isn't it? A is completely in B. So A intersection B is equal to A. And what is A union B? A union B is what? The bigger set. A union B is B. A intersection B is A and A union B is B. Now we come to the next topic, that is difference of two sets. Difference of two sets. Meaning, if A and B are two sets, then A minus B. A minus B is the set of all elements that belongs to A but doesn't belongs to B. Now, how can I write this in the set builder form? It is all X is such that X belongs to A and X doesn't belongs to B. Okay, so that is A minus B. Now, in Venn diagram, if I draw it in Venn diagram, I shall just show you so that it is much clear to you. That belongs to A but doesn't belongs to B. So this is A minus B. This is A minus B, which belongs to A. This is A, this is B, this is our universal set. So A minus B is what? It is the set of all elements which belongs to A but doesn't belongs to B. What about B minus A? Yes, you can give me X such that X belongs to B and X doesn't belongs to A. right? So how do the figure come? This is how the figure arises. This is A, this is B, A, B. This is the universal set. A minus B minus A means which belongs to B but doesn't belongs to A. So this is B minus A, right? Now, if you look at all this, A minus B, B minus A, what is our A intersection B? Do you remember me drawing A intersection B? Right? How will I draw A intersection B? This is the point of A intersection B. Right? This is set A, this is set B, this is U, this is A intersection B. Now look at this figure. A intersection B, A minus B and B minus A. These three sets, they are mutually disjoint. That is, you take these two, A intersection B and A minus B. Do you find anything in common? They are disjoint. Again, A minus B and B minus A. Is there anything in common? No, they are disjoint. You take these two. Is there anything in common? No. That means they are intersection. The intersection of this and this gives you null set. This and this gives you null set. This and this gives you null set. Even the intersection, all the three also gives you null set. So what can I say? In the set A minus B, B minus A and A intersection B are mutually disjoint. Are what? Mutually disjoint. Am I clear? They are mutually disjoint. Okay? Is that clear? Okay. Now let's see what is a complement of a set. Now here, when I discuss complement of a set, it is, I shall first draw it in a Venn diagram for you to understand, and then we will come back to the definition of it. So if this is set A, this is set A, the complement of A is this, right? In the universal set, set A is here. Excluding the set A, all other elements that belongs to the universal set comes under A complement. A complement notated by A dash, or even it is notated by A complement. What is A complement? As I said, from the universal set you subtract the elements of A. So U minus A, that belongs to U but doesn't belongs to A. That is U minus A. In set builder form, how will I write this? This is set of all x such that x belongs to where? Belongs to the universal set, and x doesn't belongs to where? This set A. So this is the universal set. This is the complement of a set. So complement of a set is given by the elements that belongs to U but doesn't belongs to A. Now let's see the properties of these. Properties of complement. Okay, so the properties of complement. The first one, as we know, the union. A union A complement. A is this. Union A complement gives you what? U. What about A intersection A complement? This is A. Intersection A complement. Is there anything in common? No. So we say that it is fine. Okay. Then we have the second property which is named as De Morgan's law. De Morgan's law. This M is capital letter actually. De Morgan's law. De Morgan's law. The De Morgan's law states that A union B the whole complement is equal to A complement intersection B complement, and A intersection B the whole complement is equal to A complement union B complement. Very, very, very important law is this. We need this in probability 2. Okay, so this is De Morgan's law. Third one. Now I shall give you an assignment. Draw the Venn diagram. Draw the Venn diagram for this and show that this is true. Okay, draw the Venn diagram and prove that this is true. Now, one of them I will show you after discussing the properties, and then the second one will be your assignment. Now, the next property is A complement the complement. A complement is what? The shaded portion. The shaded portion's complement is what? A. So A complement, the whole complement, A complement is equal to A. Now the fourth one, what is the complement of null set? It is U. And what is the complement of U? It is the null set. Am I clear? Okay. Next, there is one more result based on all these things. That is, if A is a subset of B. What did I say? A is a subset of B. Then B complement will be subset of A complement. When I say A is a subset of B, which is more? B is more. When I take the complement, which will be more? A will be more. Right? So, if A is a subset of B, then B complement is a subset of A complement. Am I clear? Okay. Now, let's see the Venn diagram for the first part of De Morgan's law. Now, De Morgan's law is what? A union B the whole complement is equal to A complement intersection B complement. Now, let me draw the right hand part. That is A union B. Which is A union B? This is A union B. Right? Its complement. Complement is what? Other than the shaded portion, this is A union B. I shall write A union B. Now, A union B the complement. That is, this is A union B. And then I shall write here, this is A union B. Okay, its complement is what? Outside this. Right? This is A union B the whole complement. Am I clear? Now, what is A complement? This is A, this is B. This is A, this is B. Other than A, I have the rest. This is A complement. Other than A, the rest. This is not there. Other than A, the rest. Okay. Now, what is B complement? B complement means other than B, this is B. This is completely B. Other than B, the rest. Okay. This is A, this is B, this is B complement. Now, A complement intersection B complement. A complement intersection B complement. Now see, look at these two figures. Which part is common? Isn't it the outer part of this A and B? Right? This part is common. That is, this is A complement intersection B complement. Right? This is A complement intersection B complement. Now this and this, how do they look? They look the same. Or I can say that A union B the whole complement is same as A complement intersection B complement. Am I clear? The second part of De Morgan's law,